Hello students, welcome to ePhysics. Students, in this video we will be discussing about homogeneity principle of dimensional analysis. So let's start it. Students, the name itself, homogeneity, suggests that we will be discussing something which have the same or the similar quantity or the similar characteristic. Okay, now so let's see what the statement says. Principle of homogeneity states that the dimensions of each of the terms means in the equation, if there is positive or negative sign, and in between those positive and negative signs, whatever is written are known as or terms. Okay, now so each terms of the dimensional equation on both side of will be same. Both side means on LHS and on RHS, all the terms, the dimension analysis of all the terms will be same. For example, we have an equation. Let us consider V is equals to U plus A T. So here we have this positive sign, therefore this is a term, this is first term, and on the right side of the positive sign, this is the second term, this is RHS, right hand side of the equal to, this is LHS, that is V. So students, the dimensional formula of this V will be equal to U, and this will be same as A into T. So okay, we will be seeing some examples as well. Now let's move to the principles of homogeneity principle. Okay, now let's move to the applications. Now homogeneity principle is used to check the consistency of the given equation, whether the equation given is correct or not. Okay, if it is following the principle of homogeneity, therefore then the equation is correct, otherwise it is not. Now it is used to derive the relation between physical quantity and physical phenomena. Next thing, to change unit from one system to the another, we use this analysis, but there is some limitations as well. As the first limitation is it does not give any information about the dimensional constant. For example, if we have the formula kinetic energy is equals to 1 by 2 mv square, we have the dimensional formula for m, we have the dimensional formula for v, but we don't have the dimensional formula of 1 by 2. So we cannot check the dimensional correctness of the constant, okay, with the principle of homogeneity. Also the formula containing the trigonometric function like sine theta, cos theta, we don't have the any of the dimensional analysis of any of these thetas. Okay, and also the exponential function, logarithm function, and all kind of things. Now it does not give any information about the physical quantity in scalar or vector quantity. Like we don't have any any of the characteristic or any of the term used in the dimensional analysis which gives the information whether the quantity is a scalar quantity or a vector quantity. Like vector velocity is a vector, but speed is not a vector, but the dimensional analysis of speed and velocity both are same. Okay, now let's see some example, or we will be solving one question related to this, because this is one of the easiest topics in class 11th physics. So let's see the question. Now let's see it over here. Students, we have equation S is equals to ut plus half at square. Now S means distance and the dimensional analysis of distance is length. So in all the terms, that is ut will be having the dimensional formula equals to t, half of at square will be having the dimensional formula equals to L. Okay, so now this was the LHS part, this was the LHS part. Now move to the RHS part. Let us consider this is equation 1. In RHS, the first term is ut. U means velocity, that is lt minus 1, and the second part is time. Time means t to the power plus of 1 if it is nothing over there. The plus 1 minus 1 gets cancelled, therefore ut ka dimensional analysis is L. Okay, and now next thing is this is equation 2. Okay, not this one. Now let's see the second part, that is half a t square. Here is the first limitation, that we don't have any dimensional analysis for any of the constants. So the dimensional formula for a for acceleration is lt minus 2 multiplied by this t square, that is t to the power plus of 2. Okay, now this plus 2 and minus 2 gets cancelled, therefore we have only L left over here. This is equation 3. Now S is equals to L. the first term on the right side, that is ut is equals to L. The second term on the right side, that is half at square, is also equals to L. Therefore, this formula is dimensionally correct. So if any of the formulas are having or are following the principle of homogeneity, then we can say that the formula is correct. If it is not following the principle of homogeneity, therefore the formula will not be correct. So this is how we have studied it, and I hope you understood it. Thank you for watching the video.